apologize for that. Sorry, guys.
Okay. You go.
All right, this is group 6. My name is Sierra.
My name is Ali.
My name is Na.
And my name is Tommy.
And we're going to be discussing the Beers Law group assignment. So we're going to start off with Ali.
Hello. So we're going to talk about the concentration levels that we calculated for each standard solution. And we have here on the right formulas that we use to calculate V1, which is the volume delivered. To do that, we got to calculate it via the formula V final, volume final minus final initial, which is right here on the right side, 3.20 minus 2.24, equals to 0.96 mLs. And that's our V1. And we use that into our second formula to get the N2. So we multiplied the concentration level, the M1 that we had, that was given to us, 3.55. We multiplied it with V1, and then we divided it by 50 mLs, which is the known volume 2. V2, and then we got 1.22, which is the concentration for the first one. And the second one, we got 2.66 milligrams per milliliters, and the third one is 5.12 milligrams per milliliters, 7.5 milligrams per milliliters for the fourth one, and the fifth one is 10.7 milligrams per milliliters. This is how we got it. This is the way we calculate it. And next, Sierra is going to talk about the plot. How did we do it in the Excel sheet?
So to make our graph, we use the Excel. We used our concentrations on the y-axis, and then we use absorptions on the x. And from here, we also applied a trend line and an equation. And we used our known absorbances and concentrations, just so we can help find the unknown. And I was going to explain how we found the concentrations using that.
So for the concentration of the side A and the side B, I'm using the trend line, which is y equal 0.1861 x plus 0.0379. And for the y value, we're gonna plug in the absorbance of the side A, which is 0.130. And then for we're gonna find the concentration, and we're gonna show for x value, which is the concentration for side A. And after the calculation, we got the concentration for side A is 0.495 milligram per milliliter. And then for the side B, we're gonna do the same thing. We're gonna plug in for the y, the absorbance of the side B, which is 0.247, and then we're gonna solve for x, which is the concentration of the side B. So after the calculation, we got the side B, the concentration of side B is 1.124 milligram over milliliter.
And then for our recommendation, we're going to do site B due to the concentration of site B being a lot higher than site A. Site B, as Na said, was 1.124, whereas site A was 0.495, which means site B would have the higher concentration of copper, which the mining company would want.
All right, thank you for your time.
Thank you.
Thank you.
Yeah.